Hey, Daniel here. Adding and subtracting rational expressions. It's similar to LCD, least common denominator. The example problem, 1/6 plus 3/4 minus 2/3 is equivalent to 1/6 times 2/2, which is equal to 1. And that equals 2/12 plus 9/12 minus 8/12, which is equal to 3/12 or 1/4.
Today we're going to be adding rational expressions that already have a common denominator. So because these already have a common denominator, we can just add the 2 and the x. So it's x plus 2 over x minus 3. And that is the answer. Now we're going to be adding without a common denominator. Since these are the reverse signs, all we need to do is make this plus subtraction, and it'll change the whole equation. So now we have 3 over x minus 2 minus 5 over x minus 2. And since these are now the same denominator, all we have to do is subtract them. So we get negative 2 over x minus 2.
Hey guys, today we'll be focusing on subtracting a constant from the problem we have here. This function can also be written as 3 over x minus 1 minus 5 over 1. Since we're trying to find the least common denominator, which in this case would be x minus 1, we'll need to move the x minus 1 up here and the 1 up here. Okay, so this would be 3. After you distribute, this would be minus 5x plus 5 over x minus 1. And after you combine like terms here, the answer would be 8 minus 5x over x minus 1. Hey guys, today we'll be focusing on factoring with wholes. So the first thing we need to do for this is factor the top, and if we split the middle, this will factor into x plus 5 times x minus 3. Alright, and then the bottom one we can factor out of 6, then that'll factor into 6 times x minus 3. And since these two are both x minus 3, we can cancel these two, which will result in x plus 5 over 6. And since we have a whole here, you set the whole equal to 0, x minus 3 equals 0. We're going to add 3 to both sides, which will x equals 3, or x cannot equal 3. Those are your answers.
Hey, focus now is the polynomials in the both numerator and denominator, along with the wholes like the last video. For the example problem, 12 plus x minus x squared over 2x squared minus 9x plus 4. Some may choose to write it like this in the standard form of the numerator. You would start this question like this. Get the negative on the outside. X minus 4, and then x plus 3. All I'm doing is factoring. If you missed that, you can go back later on and catch on to that. That's how you factor it. And as you notice, x minus 4 and x minus 4 is both in the numerator and the denominator. So you can cross those out, and that equals a whole. X minus 4 equals 0. X equals 4. So x cannot equal 4. That is our whole, which is now leaving this up here for negative x plus 3, 2x minus 1, and that's your answer.
You're going to want a common denominator. So before I look for that, I'm going to go ahead and make sure all factored. That one's factored all the way, so is that one. And then that one can come down one more step to look like that. So I'll go ahead and rewrite the problem. Okay, so it'll look like that. And then to find a common denominator, you wanna get all of these together, so to speak. So the common denominator is going to be and that's an x, by the way. It's like that because it incorporates the x minus 1, which is common already between this and that, the x plus 1, and the x. I've got all these denominators written down, and these are going to be our common denominators. But now we're going to have to find what is in the new. We had to bring in this x and this x plus 1 to get it there. So we'll have to do the same on the top, which means that the top will look like this. 3x and then x plus 1, because those are the two components that were not already on the bottom. And then the same will go for the second one. We had a 2, and the x was already there, but these two components weren't incorporated yet, that and that. So we'll go ahead and write 2 times 2 plus, I'm sorry, 2 times x plus 1 times x minus 1. Okay, so that's how that looks. And then over here we had x plus 3, and all we had to add was the x to that because those two things were already there, and then the x got added. So x times x plus 3. So now what we're going to want to do is we're going to want to distribute everything out here. So I'm going to go ahead and write everything distributed. What that looks like when it's all distributed out. And since it's all under a common denominator now, I'm just going to go ahead and write the denominator once. I'm just going to write it all over 1. I won't change it. And we're going to go ahead and combine our like terms, perform our operations here. So we have 3x squared minus 2x squared, which gives us x squared, plus x squared. So we have 2x squared. And then we have an x over here, just a 3x, and it doesn't look like that combines with anything else, so plus 3x. And then we have 3 plus 2, so that gives us 5, plus 5. And that will be written over our common denominator that we found once again. And that is your answer.